So to kind of continue with this, if you're given a function like this, you want to be able to identify all these things, the amplitude, the period, the phase shift, and if you have vertical translations and stuff like that. Those are kind of the key things like that, okay? All right, so the first thing you got to do is you got to put this in a factored form, okay? So you got to be totally on top of that, and what I mean by that is we want to bring the 3 out of the parenthesis. So you want to write that like that, and you got to be able to factor that correctly. If you don't do the factoring, that'll mess up when you find the phase shift, okay? So this goes like this. You would have an x there, and again, 3 times x is going to give 3x. Sometimes students do this part right here wrong, and really all you're doing is you're just taking that number pi, and you're dividing it by the number that you took out, so that just gives you pi minus pi over 3 like that, okay? And if you don't factor on this, you'll miss your phase shift, okay? So that's really important on that. The other thing that's real important is make sure that, before you graph anything, make sure you factor it right. So notice 3 times x is 3x. How about that? That's 3 pi over 3, right? Well, what is 3 pi over 3? Takes you back to pi, so don't start graphing anything until you make sure that you did that right, okay? Otherwise, you're just wasting your time. Okay, so let's see kind of what we know on this. The amplitude, of course, is this number, okay? And amplitude's always positive, so that's 4. We talked about that meaning stretching the waves up and down like that. Okay, the period comes from this number now, so whenever you're doing the period, the formula is 2 pi over omega, and the omega is 3 in this case, so that's going to be 2 pi over 3. So that's what the period is, okay? Now the phase shift is, you got to look at the factored form. It's there, not here. Pi is not the phase shift. So you must do that. So that would be pi over 3. Which way does that go? If it's minus pi over 3, is that left or right? Right. It goes to the right. The minus tells you to the right. Just kind of like college algebra stuff. Okay, vertical translation, there is not one, because you'd have to have a plus or minus number out there. You'd have to have like plus 5, then you'd move up 5 and so forth like that. So that's one of the first things you do in this section, is going to be able to identify all the pieces. Amplitude, period, phase shift, all that stuff before you do any graphing. Okay, does that look okay so far? Yes or no? Tell me. I don't know. Okay? Because we need to get kind of into the graphing here, and that's kind of the main thing that we're trying to learn how to do. So let's do a couple of graphs that have phase shifts. That's something we haven't done yet. So what you want to do, we're going to go ahead and look at this graph. We're going to graph this over one period without the calculator or anything. So what you want to do is you want to factor that 2 out. And you got to make sure that you're effective when you do that, okay? So let's make sure we're on top of that. So we'd have 3 times the sign, draw a bracket, bring the 2 out. Now you just got to figure out what goes inside. You can do this in your head. Okay, the idea would be if you're trying to get a 2x, you'd have to have an x there, because 2 times x is 2x. And then you just always take this number right here. You always just take that number pi, and you divide it by whatever's in front of x. And that gives pi over 2, so that would be the factored form. There's no guesswork to it. It's just strictly take this number and divide it by that number 2. Okay, like that. All right? All right, what's the amplitude? 3. What's the period? What's the formula? 2 pi over omega. Omega, of course, is that number. So that would be 2 pi over 2. So that means the period is going to be pi. Okay, and that's going to tell us that when we make our graph, the x-axis has to be different. We have to figure out how to increment that. Okay, phase shift. What's the phase shift? Pi over 2. Which way? Right or left? To the right. Okay, it's got the minus sign, so you want to do that like that. So we'll say we have a phase shift of pi over 2 to the right. Now, does this thing have a vertical translation? In other words, is the graph moving up or down? No. Does everybody understand what you would have to see if it was that case? You'd have to have plus a number or minus a number outside that. So we don't have one. Okay, so what we do now, and this is real important, anytime the period changes, you need to take the period and you need to divide it by 4. Okay, so this is what I call the increment of the x-axis. Okay, you did that some, I think, on your graphing assignment. So the period's pi, and then divide by 4. So you're going to make your x-axis go by pi over 4. Now we need to just get this set up and ready to graph. All right, is there any questions so far about anything? Okay, let's see. Let's take a look at kind of putting this together now. So what you guys need to do on this is start counting the x-axis by pi over 4. And what you do is you kind of reduce in your head as you go. I'm going to write this down. You don't need to write this down. I just want to go through my thought process. So what I'm doing is I'm counting by the numerator. 1 pi, 2 pi, 3 pi, 4 pi. And reduce the fractions as you go. So that would reduce to pi over 2. Then you'd have 3 pi over 4. Okay, and then 4 pi over pi is pi. Now every time I do this, I always like to mention the same thing. Okay, what is the significance of pi in this problem that we're working on? That's the period, right? So if you count from here to here, you should get 5 key points. 1, 2, 3, 4, 5, like that. So we've got 5 key points lined up there. Now what I'm going to do on this is just kind of go back into the negatives a little bit here. Then I'll take you through how to put this whole graph together. And our goal is to do this in maybe 1 or 2 steps. Usually I can teach you how to do all these problems in a minimum of like 2 steps. Sometimes 1. It just depends on the situation. Okay, now the other thing is the amplitude is 3. So what that would tell me is I need to go up to 3 on the y-axis, and I need to go down to -3 on the y-axis like that. So you got to take a little bit of time when you're graphing something, getting it all put together, okay? All right, does everybody understand how I got the x-axis numbers? That's the key to this problem, by the way. Period divided by 4, that's how you get that, okay? Now, what we're going to do on this is the way I generally like to teach students how to do these more complicated problems, is like this. So watch carefully, because if you follow this procedure, this makes this fairly easy. So what we're going to do is we're actually just going to graph that first. Just the inside part, okay? Anytime you have a number in front of the trig function or a number at the outside that's moving it up or down, just do that at the end. You focus on this. So what I'm going to do, watch real carefully how I do this. You want to remember, and hopefully by now you got this down, where does just a basic sign start? What's the first point on just the sign of x? Okay, if you got that down, it'll help you tremendously, okay? So I'm just going to lightly have you put a little dot there, okay? And then just kind of lightly trace these. These are the kind of the key points on a sign like that, okay? And just put those things in your paper kind of like that, and then we're going to transform those points like that, okay? Now, so we're going to do that. Now, what I like to do on this, since you have a phase shift, what you really need to do is you need to start the cycle, start at pi over 2. Okay, so you don't even have to put those dots that I put there. Really all you got to do is this. You know a sign starts at 0, 0, so if there's a phase shift pi over 2, now it's going to start there. Okay, so instead of starting there, just start at pi over 2, and then cycle. So all you're doing is moving every point over to the right, pi over 2. So let's do that, and then let's sketch that piece right there. I'll just kind of do that in like a green color or something like that. Okay, so watch carefully how I do this. Okay, this point now moves there. Okay, this point here phase shifts to there. We got that, okay? So we got that point. This point right here phase shifts to there, and then we're starting to get our cycle okay. Now once you get enough points, you'll be okay. This point right here would phase shift over to there, and so forth. Okay, so what I'm going to do is just kind of lightly sketch that in. And you know how it cycles, so once you've got that down, then you can just sketch those points kind of like that. So all I'm doing is taking a sine wave and moving it to the right pi over 2. Okay, you guys follow that okay? All you got to remember is 2 things on a sine. A sine starts there and then it hits a high point. If you remember that, that's all you got to know. So this moves there, then it hits the high point, and it just cycles like that. So is that good with everybody? Now see, the 2 that did the period change, we took care of that by re-incrementing the x-axis. So we've actually got that done. Now all we've got to do is the amplitude of 3. So what does the amplitude of 3 do to this graph? It just stretches it this way, right? Okay. And technically, you want to understand how the arithmetic works, because then you'll learn this stuff a lot better. I mean, you can do this all in your head, but like if you take this y value, that y value is 0. If you multiply it by 3, you still have a 0. Okay? So you would end up having that. So that point just stays the same. This one right here has a y value of 1. So 3 times 1 is 3. So that stretches there. This one has a y value of 0. So 3 times 0 is still 0. This one has a y value of -1. So it does that. Okay? You guys see how the arithmetic's working? That's real important. That 3 multiplies the y values by 3. And now you got the cycle. So now we can put this all together like this, and then we just sort of start cycling through the key points. You'll notice the mins and maxes are what changes, and the x-intercepts all stay the same like that. So that would be what your graph looks like, is like that. Okay? Okay, now I'm going to show you guys one more thing. This is something that I wish I would get students to do better on, because you can tell you're right on these problems. When you do your test Thursday night, you have the power to tell that your graphs are right, okay? And let me explain what I mean on that. So what we just got through graphing was y equals 3 sine of 2x minus pi over 2. And to me, if you check like 2 points, then there's probably about a 95 or 99% chance that the whole graph's right. So what I tell students to do is just pick something on the x-axis and keep it as easy as possible. Let's pick pi over 2. And I'm going to plug it in because that makes the arithmetic easier. So let's do this and see if this gives us the right point. So if I just take that pi over 2 and plug it in, I'm getting 3 sine of 2 times pi over 2 minus pi over 2, right? I picked that point because it's so easy. Now, isn't this whole thing 0? So you would have 3 sine of 0. And the sine of 0 is 0 if you look it up on the unit circle, so you get 0. Is that the y value of that point? It is. Okay? See what I mean? You can tell you're right. So if you're doing a test and you're not sure, then plug a point in. At least plug 1 point in. Make sure at least 1 point's right. Okay? 2, you're better. Does that make any sense? Tell me. Okay? So you have the ability every time you graph anything in mathematics to tell if you're on the right track with your points. Okay, what we're trying to do in these things is learn how the transformations work. So we're trying to do these without having to crunch points out. Okay, so let's move to this next. And all these things I'm going to do today have got phase shifts in it. Okay, now one thing I want you to notice about this one is it's already in a factored form. So this one's factored already. If I give you something in a factored form, then you don't need to factor it. You can just identify everything automatically, okay? All right, so let's see where we're at with this. What's the amplitude on this one? Okay, it's positive 1/2. Remember, like when on your test Thursday night, don't give me a negative amplitude. There is no such thing. An amplitude's a distance, therefore it's positive. Okay, the period. The formula is 2 pi over omega. Omega in this problem is 4. So you'd have 2 pi over 4. That reduces down to pi over 2. So we're going to have to figure out how to change the increment on that x-axis. Okay, what's the phase shift in this problem? Pi, which way? To the left. Okay, it's got that plus sign. That's what tells you that you're going to the left. Now, since you're going to the left, you want to say negative pi. On a test, I don't care. I mean, it's just the phase shift is left. That's what matters. I know my math lab, they want you to put a negative in there. So you want to pay attention to that. Okay, what does this 2 right here do? Takes you up 2. Okay, that's a vertical translation. So this time we have to also go up 2 like that. So what I'm going to show you how to do is I'm going to show you how to do this problem in 2 steps, where you can just get it all put together with a basic graph and then transform it like that. So what we need to do first is you need to figure out the increment of the x-axis, and you always do this the same, regardless of the trig function. You take the period, which is pi over 2, and you divide it by 4. Okay, in other words, just multiply by a 4th, so you'd have pi over 2 times a 4th, so that gives pi over 8. Okay, that's real crucial in this problem, is when you do your x-axis, you want it to go by pi over 8 now. Okay, is everybody solid with that? Tell me honestly and good. Okay, follow the procedure on graphing and then you'll I think you'll do well if you do that. So now we're basically about ready to put this together. So let's go ahead and just sort of sketch out a graph, and then we'll get everything kind of built and put together. We'll do this through maybe 2 cycles or 1 cycle. So what I'm going to do on this one now is I'm going to count by pi over 8. Okay, and you can just do this in your head. Reduce the fractions as you need to. So I'm going to go pi over 8, 2 pi over 8, 3 pi over 8, and 4 pi over 8. Now see, notice on this, that reduces to pi over 4, but that reduces to pi over 2, so that's the period. Okay, and that's what should happen. So if you count out your increment, you better fall on wherever the period ends. Okay, so what we're going to do when we put this together then is just go ahead and get these things labeled. You're going to have pi over 8, and then pi over 4, and 3 pi over 8, and then you're to pi over 2. And again, what happens on that's all about 5 key points. We have 1, 2, 3, 4, 5. Okay, when you get your those 5 right here, you'll have 1 cycle through the trig function guaranteed. Now, since we have a phase shift on this one now this one has a phase shift of pi. So what I'm going to go ahead and do on this one is just take this out kind of like this. And we're going to do the negatives like this and go ahead and get that put together. And then that leaves us with just kind of thinking about what you're going to do on the y-axis. Okay? Now you have a phase shift of pi, so this thing is going to the first point's going to move way over there. You don't have to take your graph out that far if you don't want to, because you can reason it out in different ways. Okay? So the other thing I want to pay attention to is what happens with these numbers right here. Okay, these 2 numbers here, the 1/2 and the 2, they will tell you how to make your y-axis. All right, tell me what the 1/2 is going to do. It's going to shrink it, right? And it's going to flip it because it's negative. Then what's the 2 going to do? Up 2. So does it make sense if you go down to 1/2 and up 2, 2.5 would be probably where your maximum is. Okay, so what we want to do is let's go ahead and just set this up like this. Let's do all the way up to 3, and then we can just kind of do halfway points like that, and then we can do the negatives the same way. So you want to reason out how to get your graph set up when you do these things. Okay, all right. So you want to draw big too, so you can see everything. Okay, so we should be ready now to put this all together. So as I'm doing this now, I want to take a real quick screenshot of this thing because I want to show you the way that you want to look at this now. Whenever I teach graphing, I try to teach you how to do all of them the same, no matter what it is. It simplifies it a little bit. Okay, now here's what we're going to do when we do this problem. We're going to focus just on this part right here, only that part there. That's the inside part. The 1/2 and the 2, that's stage 2. That's affecting y values. What you want to get in your mind is that's messing with x. Those are messing with y. So we've already got the period change taken care of by doing the increment. All we got to do is just do the phase shift now, so where we start. So you can kind of reason this out in a couple of different ways like this if you want to. All right, so first of all, on a cosine, tell me where the first point is on a basic simple cosine. 0, 1. Okay, you want to have that memorized because it makes everything go fast. So if you have just a basic cosine, and I'm going to look at 4x now instead of x because of the period, well then that point right there would really start there, wouldn't it? However, what you're doing is you're phase shifting to the left pi. So what you could do on this, now if you have to, you could go all the way back to pi and switch it all the way over there if you wanted to, or you can even go kind of like this. If you wanted to just count this out, eventually you would get to pi if you did this and this, then you would end up getting to pi like this, because if you counted this out, after 4 pi over 8, you would have 5 pi over 8, 6 pi over 8, you don't have to write this down, 7 pi over 8, 8 pi over 8 like that. So what I'm going to do is just kind of, I'm not going to label this, but I've got 5 pi over 8, 6 pi over 8, 7 pi over 8, and then finally I'm at negative pi like that. So if you need to do that, you can. Now what I'm going to do is just kind of think of this point moving all the way over there like that. And then I can just cycle. That's all you got to do, because after the high point on the cosine, where does it go? It goes down to the x-axis, down to its minimum, and cycles. So all you should have to do on this now is just kind of write these things in like this. Just kind of lightly put those values in, and then we'll just kind of take this through one cycle right there. So if you notice, we're back to where you began anyway, all right? So what happens on this one is that's going to be a first point on your graph, and then if you just sort of keep cycling through these things, it'll kind of go like that. Now all I'm going to do is like one period. We don't have to repeat ourselves and do this more than just one cycle. So that means that this graph right here, the one that I've got highlighted in yellow here, is going to really just be this graph right here. Okay, and what happened is the pi, the period on this graph was pi over 2, so that didn't impact anything. Okay, does that make sense to everybody? Okay, so those would be the points. Now, what we're going to do from here now is we're going to go ahead and just work with those 5 key points, and then we're going to transfer them, and then we'll have our final graph like this. Okay, so watch this real carefully, because now it's just a matter of doing arithmetic. So you have a -1/2 and you have a +2. So let's just start with this first point right here. That has a y value of 1, so you're just going to do -1/2 times 1 plus 2. You might as well just do arithmetic because it makes it easier. That's -1/2 plus 2. That's like 1.5 or 1.5. So that means this point right here is going to move to 1.5. So we got that, okay? Now see, you don't have to go through all this. You could say in your mind, you could say, it basically shrinks to 1/2, then it reflects, then it goes up 2, like that. So if you did those things like that, that's where you would end up. That point goes to 1/2, does that, and then it moves up 2. But you don't have to do that. You can just do the arithmetic. Does that make any sense? Tell me, you guys see what I'm doing? I have no idea. You take the y value and you multiply it by -1/2 and add 2, and you're going to be in the right place if you do that. So let's do this next one. That one has a y value of 0. So -1/2 times 0 plus 2, what's that? 2. So that means that point is moving up to 2 now. So we got that. Okay. Now let's do this one. This one has a y value of -1. So -1/2 times -1 plus 2 is going to be 2.5. That's a half plus 2, so it's 2.5. Okay, so that point right there has moved all the way up like that. Now that should be enough points for you to do the rest. What do you think? Because I got 3 points. That's the minimum. That's the midpoint. That's the max. So where's it going to go? Back down to the midpoint and then back to the minimum. Everybody see what I'm talking about? So if you got 3 points, you don't have to do any more number crunching unless you feel like you need to. So this one is going to match that point, and then this one is going to match that point right there, and then you've got one cycle of the graph like that. Okay, so what you want to try to do when you're doing these problems seriously is do the inside part, get that established, and then do the outside part. And that way you can always do these things in 2 steps. Okay, you guys follow what I did or not? Any clarification that you need? Okay, there's many ways to do this just over the years. If you kind of follow this procedure, it's not too hard to do. Okay, so that's a couple of graphs with phase shifts on this. So let's go down. What we're going to do next is kind of do this backwards. So what we're doing with this is I'm giving you information, you're writing a sine wave. Okay. So the first thing with this one is since we're doing a sine wave, you want to write down what the general formula is. So you have A sine, then you have B, or I think our textbook uses omega, so let me match what the textbook does. They use omega. X, I think our textbook likes phi. Doesn't matter, it's a variable anyway. And then just like plus B like that. So everything that we've learned in here, that's your amplitude, A's your amplitude. Omega is not the period, but it gives you a number that will give you the period. That's your phase shift. Then that's up, down like that. So let's kind of see where we're at and see what we can plug in then. So we have an amplitude of 3. So that means 3 is going to go in there. Okay, we have a phase shift of 1/2 to the right. So a half's going to go there, like that, and it'll be minus if it's going to go to the right. And then what we got to do is we got to figure out the period of pi. So you have to figure out what omega is, and then we're done basically. So the formula is the period is equal to 2 pi over omega. I gave you the period, so you're going to plug the pi into that formula, and then you'll have a simple equation you solve for omega. So you'll have pi equals 2 pi over omega, and then go through cross multiply that, and then see where that takes you. So that's going to give pi omega equals 2 pi. Okay, then you could divide by pi. So what does it look like omega is? 2. Okay. So remember, you have to find omega if I give you the period. So that goes there, and now we're ready to write the answer. That's it. It doesn't have an up-down transformation, so we don't worry about B. So that means the final answer is going to be y equals 3 sine of 2 times x minus 1/2. Okay, so that is the equation that has those characteristics, like that. Now see, we did that in an earlier section, we just didn't do the phase shift. That's the only difference in this section, is you're adding in the phase shift. Okay, how's that look to everybody? Thumbs up, thumbs down. Okay, something. Okay, give me a sign. Okay, okay. All right, thank you. Okay, let's do a cosine here. Same idea. So the general approach is y is a cosine, then you have omega x minus phi, and then plus some number b like that. So same idea. I'm giving you what to plug in essentially. So the amplitude's 1/3, so that'll go in there. The phase shift is 3 to the left, and then we're going up 4 like that, and then you got to figure out omega by figuring out the period. Okay? All right, so I gave you the period is 2. So remember, the formula is period equals 2 pi over omega. So just plug in the 2 for the period. So you'll have the equation 2 equals 2 pi over omega, and then just cross multiply to find omega. Okay, just solve that equation. That's a proportion. It's easy to cross multiply. So that's 2 omega equals 2 pi. Divide by 2. So what is omega? Pi. That's fine. Okay, omega can be pi. It can be anything. It can be any number except 0. Okay, so that means that what goes there is pi. Then we're ready to put it all together. Okay, so that looks solid. Okay, so what you'd have for your answer is you'd have y equals 1/3 cosine, and have pi there. Now, if it's left, how do you got to put that? Got to have a plus sign, right? So be sure you pay attention to that. So you have to say plus 3, and then if it's up 4, what do? Plus 4, like that. So you got to pay attention to your signs, and then that would be the solution to the problem, like that. Okay. All right, does that look good? Okay, so you want to be able to do that. We're going to be doing, I think, next week, after we're done with the test, we're going to do an application problem where you have to do this kind of thing, where you have to take a graph and write an equation for it. So we'll be kind of getting into that a little bit next week. Okay, so let's see, I want to do one more graph here. To finish this up, this is a cosecant. So mainly in this section, when you have a phase shift, what I generally do is require you to know how to phase shift like a sine, cosine, secant, and cosecant. I don't worry about the cotangent and tangent as much because it doesn't show up as much as the other graphs do. So let's go ahead and do one last one here. This one's got a lot going on in it, so you do have to do the factored form. So let's go ahead and get that there. F of x, you can write y if you want to. So we'd have 2 times the cosecant. Okay, then you want to pull the 1/2 out. Like that. And then you got to figure out basically what goes there. And don't freak out when you see that. You always do the same thing. What you always do is you take this thing, which is 1/4 pi, and you divide it by the number omega that's like that. That's what you do when you do the factoring. You take that divided by that. So if you do that, you really have pi over 4 times 2 over 1. So that's 2 pi over 4. And then that would reduce to pi over 2. Okay? And that's going to end up giving you your phase shift like that. Okay? Now, in your head, tell me honestly if you can check that answer in your head. I see students mess up on this all the time, okay? It shouldn't happen, okay? 1/2 times x is 1/2 x, right? What's that? Isn't that just pi over 4? When you multiply straight across, that's what it's supposed to be. So when you factor, make sure it's right. Okay, don't move on. Make sure it's right. Okay, now let's identify everything, and then we'll get our graph put together. So the period, remember the formula is 2 pi over omega. This time omega is 1/2. And you can do this in your head. I don't care if you do this in your head. That's 2 pi divided by 1/2. What is that? 4 pi. Okay? Yeah, when you divide fractions, you got 2 pi times 2 over 1. So that's 4 pi. Okay, so the period's 4 pi. Okay? The increment, what you always do on the increment of the x-axis is you take the period and you divide it by 4. So that's going to be real easy on this one. The period, we just got 4 pi. Divide by 4, you're going to have pi. That's super easy. You're just going to go on your x-axis, you're going to go pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. That's it. Okay, that's the significance of that number. Okay, the amplitude. Now be careful on this. I'm asking for the amplitude of a cosecant. What does a cosecant's graph look like? It's got those U shapes, right? And it never comes to an end. The y values get infinitely big. So this does not have an amplitude. Now, if I were doing a sine, then the amplitude would be 2, wouldn't it? But a cosecant does not have an amplitude. Okay, only the sine and cosine do. And then the phase shift is going to be that number, so that's going to be pi over 2 to the right like that. So we got kind of all the key information that we need figured out. Okay? Now watch carefully how I do this graph, because when you do one of these problems, if you do a cosecant, what do you really need to graph? The sine, right? And then once you get the sine, what do you look for? You look for the asymptotes, and then you just sketch in those U shapes, right? So it's all a matter of sketching. So what we're really going to do with this one is we're really going to focus for a minute on graphing y equals 2 sine of 1/2 times x minus pi over 2. Okay, so we want to get that taken care of. So let's go ahead and just get us a kind of a graph put together. And we'll graph this over at least one cycle. And we have a phase shift. I usually just kind of have you do maybe one cycle or something like that. So, okay, so we got everything kind of put together. So the increment of the x-axis was pi. So what you need to do is just go ahead and, count by pi, get your x-axis put together, because that's going to tell you where your key points basically are. Okay, we may have to subdivide this thing a little bit though. So I'm going to go pi, 2 pi, 3 pi, 4 pi. You can go out further if you want to, like that. Okay, and then you can do the negatives like that. Okay, now we got that. Now if you look at your graph, okay, what's the amplitude of the sine? What's the amplitude of the sine? 2. Okay, so it makes sense that you probably go up to 2, right? And then have a little bit of room for the U shape. So what I'm going to have you do on this is just go up to about 2. That's all you got to show. But just have a little space above and below like that. So now we're all set up and ready to go. Okay, so here's what you want to do on this. Okay, you really want to try to do this, and you can learn to do this in one step. You really can. Okay, so where does a basic sine start? It starts there, right? Okay, what you're going to do is phase shift it pi over 2 to the right. Well, that's kind of halfway between 0 and pi. So it makes a lot of sense on this to kind of subdivide this. The phase shift doesn't have to fall on those increments. It has to fall somewhere. So what I'm going to have you do is just kind of subdivide this like this. Okay, like that's a pi over 2. You don't have to label that. I don't care that you label that, but just kind of subdivide it like this. Okay? Now, what we want to do on this, and you do this in your head, okay? You know that the first place on the sine is there. It's going to move there, right? Okay, then the next point is going to hit the high point, but the high point's now going to be 2, right? Okay, so what you're going to have is there, kind of cycling through like that. So if you have a phase shift, the way you ought to do the graph is that ought to be point number 1. So that's what I'm going to have you do is just, in your mind, you know 0, 0 is the first point. It goes there now. Okay? Then the second point is going to hit its maximum. Now, see, I got to go halfway in between now. Okay? Then I go up to 2 because of the amplitude. Then I'm ready to come back down to the x-axis. Then I'm ready to go down to the min like that. And then I can just kind of work backwards with the cycle. So I'm going to have you kind of go like this. This is ready for the min. And then back to the midpoint. Back to the max. And then back to the midpoint like that. Okay, now that would be the graph of the sine. So I did that all in one step. If you have a phase shift, that just tells you where to start. Okay? So does that make sense to everybody, okay? Sine starts at 0, 0, but it phase shift. Okay? Then the next point's the high point, but the amplitude changed to 2. And once you get those points, then you can figure out the cycle. Tell me if that looks okay. Okay. Now, tell me where the asymptotes are. What do you look for on the asymptotes on this problem? Yeah, really a midpoint. You're right, though, on this one. The midpoint would be this, and this right there. Don't think of it as x-intercepts. Think of it as midpoints, because if you moved this graph up or down, the asymptotes are still in the same place. So what you want to do on this is go ahead and put your asymptotes at the midpoints like that. Then we're ready to sketch the graph, and then we're done. And then I'll show you how to check maybe like 1 point or something. Okay, and then the U-shapes, just sketch them the right way. They don't have to be super accurate. Once you get the asymptotes and the sine, then you've got the framework built to where it's pretty easy to do this thing then. Okay, like that. So now we just do that. My teacher told me years ago that's the hump of the camel's back, and this is the camel's belly. I still remember that after all these years. So then you just sketch that like that, and then you got that through more than one cycle. Like that. Okay, so that's how you would do a cosecant if you had a phase shift. That's the only new thing that we're putting together on that. Okay, and I'm going to have us do a couple of other things with this, with the asymptotes, and I'm going to do a check on this also. So what I'm going to do on this is we're going to look at, I'm going to write down the cosecant. We have 2 cosecant of 1/2 x minus pi over 2, like that. Now let's check 1 point. Okay? What would be a good point to check on this one? That would make it super easy. Pi over 2, exactly, right? Okay, keep it as simple as possible. What we found is when you're at pi over 2, the cosecant's undefined. There's an asymptote there. So if we plug in pi over 2 and crunch it out, hopefully we're going to come up with something that's undefined. And when you do this, this ultimately helps you understand how graphs work better anyway. So let's go ahead and take pi over 2, plug it in, and do this. So we have 2 cosecant, 1/2, pi over 2 minus pi over 2, like that. So you can do this all in your head. So that is 2 cosecant of 0. That whole thing's 0, right? Okay. Look at your unit circle now. Okay, when you're at 0, how do you find the cosecant anyway on a unit circle? You do the reciprocal of the sine, right? Isn't that undefined? Yeah. So it's got an asymptote. You just proved to yourself, since that's undefined, that that's an asymptote. Okay? That right there is undefined. And see, that's all it takes in general to tell if you're on the right track. So students hardly ever do that. I don't know why. It takes no time at all. Find out if you're right. You get the point? Okay, so when you're doing that test on Thursday night, find out if you're right on these things. If you check 1 point, it helps. Okay, I'm going to do one more thing, and then that'll kind of close this off. And I think we'll just review for the test the rest of the time. That'll give us about 30 minutes of review time. That should be fine. So the other thing I want to do is the vertical asymptotes. Now, I taught you a formula, and this is a problem where it's real hard to figure out the pattern on this. This has got some weird asymptotes. So the formula is x is equal to, I usually just have students do like pick an asymptote. I don't care which one you pick. Usually just the smallest positive one. Okay, then what you do is plus 1/2 the period times k. This is in your notes. We've kind of went over this before, so it's helpful to know that. I'll never give you that formula, but you need to understand it. When you write the equation of the asymptote, our first asymptote's pi over 2. And what happens right in the middle of a period, don't you have an asymptote? Okay, so let's just say at half of the period, we're going to have another asymptote. And k is going to be an integer. If you use this formula, k is not odd or even. It's always an integer. So what we would do to get the equation is just say pi over 2 is our first asymptote, plus half the period. I forgot what the period is. What did we find? 4 pi. So we say half of 4 pi times k, and then we just say k is an integer. You can use the symbolism, or you can state that it's an integer. So we would end up having x is equal to pi over 2. Half of 4 pi is 2 pi k. K is an integer. So that formula will take the guesswork out of this, because sometimes it's too complicated to see a pattern. This is a good example of that. There's your equation, your asymptotes right there. Okay, does that make any sense? That part right there is something students do not do well on in this class, is generally finding equations of asymptotes. If you know the formula, you get a piece of cake. Okay, all right, or otherwise look for the formula. Okay, so that'll kind of wrap that up. Let me close off this. Oh, did I record this? Yeah. Yeah, there we go.